Let's showcase how to run batch jobs in Pumas. A batch job is a script along with some bundled data and other files that you send using GitHub to a cluster so that it runs in parallel. And it's very powerful. You can run in very big clusters, like thousands of machines, and something that takes maybe weeks or months to compute, you can compute in like 1 or 2 hours. So they are really powerful. This is a common pharmacometrics workflow that I'm showing here. I have a modifier, 01.mod.jl, and this is the simple one compartment model. Nothing fancy going on. I have a fit file that I use Pumas, CSG and serialization. I source the model file. I read the data. I parse the data into a population. I fit the model. And then the result of the fit, I serialize as a binary file with the JLS extension. And this I already ran, so you can see the JLS file here. It's a binary file. We cannot see it because it's binary. It's a serialized file. So how do we run a batch job in Pumas? First, we need to understand that we need to create a script that is going to be run in a cluster, in a distributed manner. And this is what I'm doing in this ZO3 distributed bootstrap.jl file, this file here. I'm putting several information outputs here so I can have those printed out in the logs. This is a good set of practice to log all of the things that's going on in your script. So this is easy for you to debug if you run into issues during the batch job. First of all, we need to import the distributed package. This is actually not a package. This is a standard library module from Julia. And it provides this everywhere macro. So this at everywhere is, it will execute the statement and in every one of the distributed machines that the cluster is running. So since I'm doing a bootstrap distributed calculation, I need to have Pumas available for every machine in the cluster because bootstrap, the import function, is a function that exists in Pumas. I also want to serialize my result because this is the file that we're going to get from our batch job result. So I'm going to use the serialization standard library module as well. And the first thing that this script does, it visualizes the fit result. It creates a temporarily file name using a tank name, which creates a temporary file. And then we add their JLS suffix. This is string interpolation. So let me show you what this is doing under the hood. Let me open a terminal here. Let's run those lines of code here. There you go. And now let's see. So the take name with the string interpolation for the .jls, it's going to return a file name in a temporary file name that has the JLS extension. And then finally, I save this file name in the results file environment variable. So this env all uppercase, it is pretty much all of your environment variables that you'll have access is the dictionary. So as you can see, I got like a bunch of things here. So I have my Judah Hub, user email, a bunch of things here, and this in the dictionary. So this operational line then is creating a new entry called results file, which is the file name. This is very important because once your batch job is done, Judah Hub will search for the results, the file inside the environment variable called results file to upload as a result. So you need to make sure that you are specifying the right file name to be saved in the results file environment variable. And this is what we are doing here. And finally, this is the most important part. So this part here, I'm performing a confidence interval inference of my feed using the bootstrap inference method. And I'm overriding the ensemble algorithm, keyword argument, to be ensemble distributed. So ensemble distributed runs this in a distributed fashion. So it runs this in a cluster distributed context. So this is what it's going to be run when we submit the batch job. And of course, samples, I can put like 10,000, but here I'm just putting 1,000 samples just to showcase how you would run a very big parallelizable computation in a node, in a very big node with a lot of machines. And once this is done, I'm going to print out information that I'm serializing the results, and I use the serialize function, and this is going to serialize my CI bootstrap into the result file name. That is the file that's going to be uploaded as a result. Of course, there are like several other file extensions that you can use. Someone could, for example, save a CSV, and then your results file would be a CSV file, for example. But most of the time, you'll be working with GLS, Julia Serialize files. And this is what this file is doing. Finally, I'm showcasing also the Julia bundle ignore. So suppose that I have like a big file here, and this is represented by this big nonsense.data file. And this file tells us that it has a ton of data and several gigabytes of data. And the problem is that we have a hard limit of 2 gigs of data, 2,000 megabytes. So we cannot send to a batch job more than 2,000 gigabytes. We would need to use the data sets functionality that we also covered earlier in this onboarding course. So in order that this file is not included in the bundle data that is sent to the backshop, I created a Julia bundle ignore. This is similar to a Git ignore or a Docker ignore file, if you're familiar with those things. So anything that I put here, Julia Hub will ignore when it's creating the bundle to send to our batch job. So here I'm putting my big nonsense data. But suppose I have like a data folder. You will do something like this, data /. So this would ignore all of the contents, the whole folder, the whole directory data. And I can put several other things here. So this is similar to the other .ignore files that you encounter in the wild. Now, how do we right now? So let's do this batch job. So we go to our Julia Herb extension here. Let's close this. These are our previous jobs and our data sets. I want to focus on the Pumas AI Julia Hub. This is the part of the extension that we are going to use. So which Julia script do we want to run as a batch job? Is this one. So use quantifier. So it's this 03 distributed bootstrap. That's the one. So it needs a directory. So we need also to send a directory because this script here is deserializing something. So it needs to have access to other files. So we are going to send this as a bundle directory. So let's select the directory that we want to send. And yes, is it directory that we are currently on, these batch jobs here? Yes, that's correct. This is the directory that we want to send as a bundle. So node type, which machine, which type of machine our nodes will be made of, will be composed of. I'm going to use a standard 8, Virtu CPU, 64 gigs of RAM. And of course, I want to run these in a distributed node. I want one process per node. And let's say I want, let's do 20 machines. And this is telling us that we are going to, so 20 nodes, 20 machines. This means that 1 will be the master node and 19 will be the worker node. So let's increase this to 21. So that 1 is the orchestrator, the master node, that will orchestrate the other 20 machines that will run the distributed bootstrap. Of course, let's keep 2 hours. This is a trivial task. It's 1,000 bootstrap samples on a info, data, and model. So I'm going to leave it like 2 hours. You can also leave unlimited if you want to. Just be careful. And I need this to run in a Pumas image. So this needs to have access to Pumas. So if I go with the default, which is Julia, once it hits this line here using Pumas, it's going to error out. So I need to run this in a Pumas. There you go. And you can give it any name here. By default, it's batch jobs. And we are good to go. Let's start the job. And we are starting the job. And let's wait. Okay, job has started successfully. So let's close this and let's take a look at our jobs. As you can see, we have these batch jobs here. We can check the logs. So if you click view logs, it's going to open as a new window here. There you go. And it's going to start streaming the logs to us. Right now, we don't have anything because it's still spinning up. It's still spinning up in the nodes. Please wait. And if you go back to our Judah Hub and we take a look at our jobs, you see that we have a new batch jobs waiting here that is submitted. This is a previous one that I was testing stuff, but this is a batch job that we just submitted. This is the JRGPJ and something. So I'm going to pause the recording and I'll be right back once this finished. It will take like 5 minutes like the previous job. So I'm going to pause it now. Okay, so we are back. And as you can see, it has uploaded the file here. And job stats update successful. And if we take a look, our batch job has a tick mark. It means that it was completed. And we can check that it has a file here called JL. This is the result file, as you can see. So we can download this file. So this is going to download, or we can copy back. So let's copy this path here and let's open a new file here. Let's call this 04 results.jl. And let's do using serialization. There you go. And let's, this is my CI bootstrap is equal the serialize, and it's file name here. Let's see this work. And I hope we have the bootstraps. Just be mindful that this is in a temporary folder. So one thing that I will do is serialize this back again. So let's do this like bootstrap .tls, and I want to serialize my CI bootstrap table. Now we have created this file here. Now it's safe. This folder is, so if I do pwd, we are inside our code folder. So yeah, this bootstrap.tls is persistent across apps and across shutdowns. So that's how we do a bootstrap get a distributed job, a batch job in a distributed manner. So that's how to do it.